All right, today we're going to be looking at 3D figures and looking at surface area and lateral area. Our objective for today is we will be able to use formulas for lateral and surface area of three-dimensional objects to solve real-world problems. So remember that this area is the space covered in 2 dimensions, and we're going to use square units such as meters squared, inches squared, and units squared. Think of something like painting a wall. Or carpeting. A floor. Surface area is the sum of the area of all the faces of a solid. It's still 2D units, so square units. It's something like how much wrapping paper you would need to wrap a gift. So wrapping a gift, we're just covering the entire outside. Or how much paint it would need to cover a block. Lateral area is the sum of the area of the lateral faces of a solid with a base. So basically, the lateral faces are just the sides, not the bases, so not the top or the bottom. So this would be something like the fabric of a tent, or the label on a can of soup or a can of vegetables. So let's first look at this cylinder. How much paint is required to cover everything except the bases? So when it says except the bases, that means that it's lateral area. So we know that lateral area equals 2 pi r h. So 2 pi, our radius is 5, our height is 8. Type that all straight into the calculator, and we get a lateral area of 251.3. We're measuring in millimeters, and area is square units. Now, this formula is pretty straightforward. Having the radius and the height, those are typically labeled. Maybe we have to figure out the radius from a diameter, but that's about it. In the formulas for something like a pyramid, there's a little more work involved. So remember that L is this height here, the lowercase l, okay? Uppercase B is the area of the base, like we have here. And lowercase p is the perimeter of the base. So a square pyramid means that the base is a square that is 4 meters tall. So our h is 4. Has a base that measures 6 feet long. So this side is 6, and this side is 6, and this side is 6, and this side is 6. All the sides are 6. So for the perimeter of the base, we have 4 sides that are 6 feet long. That adds up to 24 feet. And actually, I just realized there's a typo. This should say 4 feet tall, not 4 meters tall. Then, for the area of the base, to find the area of a square, it's just length times width. So it would be 6 times 6, so it is 36 feet squared. So how many square feet of paint are needed to cover this entire pyramid? Since it says entire, we know that that's surface area. So the surface area equals 1/2 of L times P plus the area of the base. We don't know what L is, but if you look, we can make a triangle using this to the base there to there. See that right triangle? So here's our L that we're looking for. We know the height is 4. Since the entire length of the base is 6, the height is right in the middle of it. So we know that that's halfway. So half the length of the base would be 3. So we know that L squared equals 4 squared plus 3 squared. Either solve the Pythagorean theorem, or you might remember that 3, 4, 5 is a Pythagorean triple. So L equals 5. So we know that our surface area will equal 1/2 times 5 times our perimeter plus the area of our base was 36. And type that all in our calculator, we get that our surface area is 96 feet squared. How many square feet of painted are needed to cover the pyramid, but not the floor, which would be the base? So this is lateral area. It's 1/2 L times P. So just this first half here, LA equals 1/2 times 5 times 24. Type that in our calculator and we get that lateral area is 60 feet squared. Let's try one again where we have two shapes combined. Find the surface area of the following solid. So we want to know, basically it would be like if we were putting a wrapper on the ice cream cone. So we need to make calculations for the ice cream part and for the cone part. So we want the surface area of the ice cream, but remember we only want half of it because it's just the top half of the circle. So it'll be 1/2 of 4 pi r squared. Since it tells us it's 8 is all the way across, we know that our radius is 4. Sorry. So surface area will equal 1/2 times 4 pi 4 squared. We're going to leave out the pi when we type it in our calculator to make things easier for when we combine them. And we would get that it's 32 pi. Now for the cone. I know it said surface area here, but as far as this whole figure, the base of the cone is touching the ice cream. So if we wanted the surface area, if we were going to cover this in a wrapper, we're not going to stick the wrapper in between the cone and the ice cream. We're not going to use this base. So for the cone part, We just want the lateral area, which is pi times r times L. Now, we weren't given L. L is the diagonal. So, if we look, here we have a triangle. It's 4 here. We know the height is 12. We want to know what the slant height is, the diagonal height. So we know that L squared equals 12 squared plus 4 squared. So L squared equals 160. So L would be the square root of 160. 160 is not a perfect square, so we're just going to leave it like that to plug it in. So pi times 4 times the square root of 160 would be 4 pi root 160. So we're going to add those together. You can type it in your calculator, 32 pi plus 4 pi square root of 60, and it would tell us that the surface area of this shape, our ice cream cone, is approximately 259.48. We are measuring in centimeters, and it is area, so it's centimeters squared. And our last example. You're wrapping a present in the shape of a triangular prism as shown. Find the minimum amount of wrapping paper needed to cover it entirely. So again, triangular prism means that the bases are the triangles. Remember, the distance between the bases is the height, the h in the picture. Since we're wrapping it like a present, that's surface area. And our formula for surface area says HP plus 2B. So P is the perimeter of the base. Remember, we have 16 and 12. This side, we know from the other base, is 20. So the perimeter would be 16 plus 12 plus 20. So the perimeter would be 48. Since our base is a triangle, we use the area for a triangle. So the area of the base will equal 1/2 the length of the base times the height of the triangle. Remember, we're just dealing with the triangle in this part, not the h for the prism. So if we redraw it over here, make it a little easier. For the triangle, this h is the 16 and the b is the 12. So the area of the base is 1/2 times 12 times 16, which gives us a base area of 96. So the surface area is the height of the prism, 10, times the perimeter of the base, which was 48, plus 2 times the area of the base, which was 96. Type that all in your calculator. We get that the surface area, 672. We're working with centimeters, and since it's area, they are squared. Fill out your summary, and we'll see you in class.